Right now I'm showing the image here of the SX12 solution. This, featured in front there is the total station scanner. So this is the SX12. And in the background, you can see we have other key components, which would be, of course, the field data collector with Trimble Access software, and also with Trimble Business Center for working in the office with that. Um, just a quick overview of what we were going to try to get through this morning is a good look at what the total package is. And then I've got a couple of videos that are kind of thrown in there. And why videos? Because you guys can of course watch videos on your own at any time, but this was our attempt to try to make this interactive, showing you what the steps are in the field, as well as the steps to bring it into the office software. So these are all short 1 to 3 minute videos. And the idea is, just to slow things down, take a more detailed look at what that looks like. And then, of course, as questions come up, feel free to put them in the chat. And then at the end, of course, we'll have, a little more dedicated time. But I appreciate, anyone just jumping in at any time, using the chat, or, Troy or anyone that wants to comment on things. That really helps things along, I think. So to get into it, again, the full system that we talk about when we're talking about the SX12 solution isn't just the instrument or the sensor in the field. Really, that's the portion of the collect, which is going to be, the sensor as well as the field software, which really gives you the capability to easily collect data in a survey type workflow, as well as to generate some deliverables in the field, to do some quality control in the field, to be able to really assess the quality and the level of coverage that you have, so that the idea is that minimizes rework that you would have to do by being able to see what you have in the field real time. And then the mid kind of tier there is the process. So we're going to be looking at Trimble Business Center today as the solution for processing SX12, along with any other Trimble geospatial survey type solutions as the main powerhouse for that. The data that SX12 collects is possible to go into other packages, but we're not going to really get into the detail of that today, but we just wanted to mention that. And then, of course, the final step here that we're going to try to at least give an overview of is the delivery process. So what final deliverables you can generate in Trimble Business Center for visualization or sharing projects with other clients, and how that would work. One of the applications we have is this web-based tool that we call Trimble Clarity, and that's something that's really easy to share and as well as to prepare and to upload to it. That's a pretty automated process. Looking at the ecosystem of the SX12 solution. So again, the data collectors that have basically the Windows operating system, those are the ones that are going to be running the Trimble Access that works with the SX12. And the reason for that is, just that more robust solution as far as having the processing power and the screen real estate to be able to visualize the 3D data in the field. So you can manipulate the 3D data. You can, you can even generate some deliverables, create a volume from point cloud data. You can easily visualize between different scan setups or station setups to be able to see the quality and the quantity of the data, so that if there are shadowing from obstructions as you were in the field, collecting data, you can easily see that and take action, as opposed to having to come back to the field after you've discovered that in the office. So that's kind of the idea there behind those. So most of these screen images that we're showing, it's the Trimble TSC7 data collector, and that's in that form factor that most people are familiar with, where it's a handheld with the full keyboard, with physical buttons. We do have field data collectors that are more like a ruggedized field tablet, and that has kind of like an on-screen keyboard. But the vast majority of users do select something like the TSC7 that's there. And then today, as I mentioned, we're going to show the workflow into Trimble Business Center, really going into RealWorks as far as the import and processing is really similar. Where they kind of diverge is the type of deliverables that you'll be generating. Trimble Business Center is a little more focused on the typical, traditional geospatial customer, whereas RealWorks is going to be a little more focused on the scanning type customer and being able to generate, more 3D models and different tools of that nature. There's a variety of applications that we see that SX12 being well suited to serve. So it's really a versatile tool, and there's a variety of things. We'll kind of take a deeper dive into, things like boundary survey, topo and stakeout, as built. But all of these are great tools, great applications that this is well suited for. I'm not going to go through all the specifications, but just to reiterate that this SX12 at its core is a high accuracy total station. It's a 1 second angular accuracy, and then when you look at the scan data, it's a very consistent 1.5 millimeter range noise all the way up to 200 meters. And another key feature to be aware of is that small laser spot size. So even 100 meters away, it's about a 14 millimeter diameter. And so what that allows is a more detailed, more accurate data collection for varied surfaces and terrain. So you're able to get through, whether you're doing a scan of an interior structure, you're able to get more detailed resolution, as well as if you're kind of scanning through, objects that have kind of varied surfaces, to be able to get through and get as much data on the area of interest that you need without it being obstructed, and also to be able to pick up more edges for a good definition, whether it's a corner or a wall. That's something that's a big benefit. And then at the bottom there, we're talking quick data capture. So even at long range, it's a pretty consistent scan measurement rate. That's at 26,600 points per second, up to 600 meters. And then when you're measuring in a total station type mode, like with the EDM, so that's about 1.5 seconds when measuring to a glass prism, and about 1.2 seconds when you're measuring in DR, or the reflectorless type mode, for taking individual discrete measurements, using the EDM. Quick look here at the type of technology that makes all this possible. We call this the Trimble Lightning 3DM band scanning, and the key component in this solution is this rotating deflection prism. So when you begin a scan with the SX12, you'll actually hear this prism, which is inside the instrument, spin up to be able to utilize this technology. And what this does is, instead of measuring one point at a time, it actually captures a band, or like a swath of points as the instrument rotates. So think of this as kind of like taking a paint roller and rolling points on the wall. So these all have a consistent point spacing, and it's capturing that full swath at a time. And this is what really facilitates that 26,600 points a second. So you might wonder, well, how do you get a more dense scan if everything's that fixed spacing? Well, what we do to accomplish that is we'll do multiple passes. So this standard course mode is essentially just one pass that gives you that fixed spacing, and then to accomplish a more detailed scan with a higher number of points, the higher number of point density, we go back and it'll do multiple passes. So that course mode is just going to be one pass at the area that you want to scan, and then there's 3 additional levels to scan at a higher density. And that's useful for longer range scans where you might want a higher resolution or higher detail, or if you have an interior where there's something that's a type of surface that has it's pretty irregular and you need very dense spacing. You can frame an area and do that higher density. But in general, when you're doing a 360 scan, the default that we start with is just that course scan, and that's something that it really doesn't take long. It's just just over, I believe, about a minute for that course scan, and then every time you go up for that higher density, it will take a little bit longer. So that's why we would frame an area typically if you're going to do that higher density scan. You might notice that the SX12 does not have an eyepiece, so we accomplish that that instrument perspective by utilizing our vision system. So this is an onboard system with 4 integrated cameras, and this allows you to have that instrument perspective on the data collector. So within Trimble Access, this is what you see. So you can be out, you could be behind the instrument, but it's more useful always to be where it is you're trying to collect the data, and that way you can easily see what you're trying to collect. You don't need to stand directly behind the instrument. You can set up the instrument at any height. So if you're in an area with busy cars, like shooting across the street, you can set it up higher. You can also use this to document any shot or setup. So this is where you might want to collect an image. So basically from any image that you see, you can save these to your project. And not only are you getting that kind of that high quality information that you can see in the image, it's also a georeferenced image. So when you bring it into the office, you can actually see it co-located with the point. When you open up that station-based view in the Office software, you can even go in there and you can create virtual survey points on the image because the image is georeferenced. And of course, Total Station is set up with that survey workflow, so it has orientation and it knows, where it is. So that's really useful. And then, of course, while you're working robotically, you can see what the instrument sees. So this is a huge benefit if you're in an area with obstructions, whether it's a busy construction site or you're working through vegetation, and for whatever reason, you've gone behind a tree or you've gone behind, a bulldozer or something. You can easily you can look up from the rod, of course, to try to find the instrument, but now you have the ability to look from the instrument to see the rod. So you can easily say, hey, I can see, you might see the, a case or a set of lath or something that, next to you, and then you can easily see that, oh, hey, if I raise the rod up a little or drop it down, that's all I need to do to get a clear line of sight to be able to take a measurement. So that's really a good perspective that helps, with efficiency and without having to walk back to the instrument, or to have to, you know, break out a radio and have someone, you know, help you out on that. Another camera there on the left, you'll see it's the, you know, showing the, you know, control point. So that's the plummet camera. So the instrument has a downward facing camera that is used not only for setting up the instrument, you know, the station setup, it's also can be used for documentation. So it can collect a point there that's going to have all the station information, as well as, you know, how well it was leveled over the point. And that's really useful to have. You can take that as you're doing your setup. You can take that, you know, at any point throughout the job or at the end of the job before you break down to make sure, you know, nothing was kind of, you know, accidentally bumped. And that's useful to have. Let's see here. This actually, I'm gonna take a look at this one a little bit later. I've got a couple of videos there. Let's skip this one for now. But this one, this slide here, we're talking about some of the differences between the Trimble SX10, which was really the predecessor to the Trimble SX12. So we've made some changes, and a lot of these are have facilitated improvements in the vision system. So you can see some of the cameras, the resolution has increased, which this facilitates a little bit longer zoom capabilities. So this is using the telecamera view. So this is like looking through the eyepiece of, you know, a Trimble S7 type instrument. So this is going to give you far more detail and magnification than you get in something like a Trimble S7. So you can easily sight things, you know, whether it's in a darker environment or a little bit harder to see. The video actually gives you tools that you would not have on a traditional total station. So if you need to, you can go in there and you can, you know, have it, the camera will give you the capabilities to see something where you can adjust the contrast or the exposure. So these are optional tools if you find yourself in a situation where, you know, you're trying to sight something that's a little bit harder to see. And then the overview and the primary cameras, those are used mostly for positioning the instrument. So here I'll move on to the next slide. And kind of this gives you the capability to kind of see what the instrument's looking at with the different cameras. So that the bigger yellow box there, that's the overall view. That's kind of like the primary camera. So you use that to kind of to start to zoom in to pick out where you are as far as what you're measuring, or to take a reflectorless measurement. So that's really useful for that. The other thing you can do is, you know, if you're going through vegetation, when you're on that primary camera, it has the capability to use a target identification light. So then that the instrument actually will flash kind of like a strobe type light, which picks up really well on the glass of the prism, so that you can easily see where the prism is. So when you want to actually lock onto the prism, it's as easy as tapping on the screen where you see that flashing light, and then it'll lock and kind of and track the prism. And if you look within that yellow box, there's a smaller green box that's you know, much smaller. That is that telecamera view. So that is like looking through the eyepiece of a traditional robotic instrument. So that's about the range of the field of view that you'd have from that solution. And additionally, that is the window or the size of the tracking system. So the tracking system is really kind of that laser almost size focus. So a much smaller field of view. So it's not going to be susceptible to other reflective objects that are outside of that frame. And then even within that frame, we use a solution that works to detect the prisms and then it once it's tracking that prism, in essence, it creates kind of this thumbnail or imprint of that prism. So when there's a substantial change, whether it's you're going right behind a stop sign or some other reflector or even another prism, it'll detect that significant change. So it will know that there's something different there. And if you have it set, you can have it basically tell you that the target's lost, and that you can reestablish tracking the prism. It does have the ability to do a search where it's just panning back and forth. But as you see on that previous slide, that's just that really small green frame. So if you're doing a long range on a big site like this, we recommend that you use this primary camera view, and then basically you just go in and just tap where you are. So in this situation, if you were near this white building right here on the edge, all you do is just come over here on the data collector, tap on that, and then the instrument would turn and lock right to that prism. It's easy as that. And then for more details on this tracking system, we do have a white paper that's available to give that information. Let's see here. The laser pointer is another big improvement in the solution that's unique to the Trimble SX12. So this provides this green focusable laser pointer. Let's see here. And this has the spot size up to about 50 meters is 3 millimeter spot size. So this is something that is helpful if you're doing like some kind of layout or where you need to mark, take off for an area. It uses two different sources, so it's optimized for both high precision and speed, and that's the EDM. Whereas the laser pointer is optimized for visibility and safety. So it's an eye-safe laser. Both of them are coaxial, and this is a system that we have that really is unique to the SX12. Since they're coaxial, the collimation errors are compensated for. So for EDM and standard mode or marking off the points. So now this portion, I wanted to take a little bit of time to go into the data collection with the Trimble Access field software. So again, the Trimble SX12, we're going to be working with the data collector like a TSC7 that has the Windows-based solution. It's currently supported in these different modules. Today, we're going to be a little more focused on general survey, which is that's the bulk of what customers are using, but it is also supported with these other applications. This is a quick video that I'm going to show. This just kind of highlights how the SX12 is a great instrument for boundary and control surveying. We're going to see how to do a quick station setup and what some of the benefits are of that survey type workflow, and being able to not only collect data, but to be able to set it up to be ready for anything, for scanning or for collecting data. So just give this a second to load, and then this is really a short video. It's about 1 minute, I think. Let's see here. Audio does not appear to be coming through. Let me reconnect here. Let me try one more time. So I'm not sure why the audio is not working here. Well, I'll talk for Riley. How about that? So essentially what Riley is going through here is talking about what's unique with the Trimble SX12. You're able to use it in a robotic type scenario, selecting the prism when you're out at the rod, to be able to use it to do a station setup. So in this case, he's showing real quick doing setting up on a known point. So here you can use the cameras to easily identify and select the target. You can measure rounds, so it's a phase 1, phase 2 type measurement. And here, it's a really efficient workflow. It's going to be able to collect phase 1, phase 2, and get through that pretty well.
Hey, Chip.
Yeah.
Just wanted to let you know that you can always share the link to that video in the chat if you want. If anybody wanted to see that link, and they can, I don't know if that's possible for you to put that in there after you get finished with your presentation. But
Yeah.
that way people can download it and see it.
Sounds good. Thanks, Troy. Here's a screen here showing some of the laser pointer settings. So this is going to show the ability to select different environments that you're going to be working in. So if you're in a low light type environment, it's basically going to project the beam at a lower intensity. So that makes it look a little more defined. When you're out at a standard or extended range flashing, those are going to be for environments that aren't as dark or longer ranges. So to give you that flexibility depending on what your environment is. Let's see, this video here was gonna talk about, the video, the stakeout. So I'll go ahead and show this too, because that gives you a visualization of what the laser pointer looks like as well. So he's talking about using the SX12 for stakeout. So of course, it's tracking you, and you're able to easily set points. So it's going to show you your, in out measurements. And then also we're going to be looking at the laser pointer example here. Again, these are pretty short videos. So here they're going along, setting out. So there's one bright light, which is his headlamp. So the small green laser there, that was the laser pointer itself. I think I have another image here a little bit later on that shows that a little bit easier to see. This is another newer tool within Trimble Access. So this is in the field. You can easily compare scans from SX instruments to reference surfaces. So that gives you that in-field comparison to a plane or a cylinder, so you can easily create that inspection map in the field to be able to generate that deliverable right there on site. Another change that we have with the Trimble Access software is this ability to do repeated scan frames. So you can essentially save a frame or load one up from a previous scan, and then to do a rescan. So if you're going to do some kind of a monitoring or if you need to go back and rescan maybe an area that might have had an obstruction, but this is really useful for construction projects as well as campaign monitoring. This is the scan limits and panorama with any camera. So previously you could only do a panorama with the two wider frame cameras. Now we do have the ability to do panoramas with the telecamera. And why is that important? Well, essentially if you're doing a longer range scan, and let's say it's framed, but it would only be one image on one of the wider frame cameras. Well, this allows you to get that higher detail or more pixels essentially with that telecamera view. So that's something that that's a big improvement and really useful in those longer range type situations. Let's see, this video was just talking about how.
Hey, Chip, we had a question.
Yeah.
The question was, how far have we seen the SX12 scanning to asphalt?
Hmm.
Do you have an idea on that?
You know, I don't have a specific number on asphalt, but if you're talking about, you know, there's two factors that would impact that range. So one, it's the dark surface, and two, it's that flat or oblique angle. So that 600-meter range is really to kind of an average grayscale reflectivity, and typically more of a right angle. So I would say, in my own experience, you should be able to get, you know, at least a few hundred feet, depending on what the material is, you know, and you know. But Troy, what experience do you have with that? Have you? Because we don't really list a specification on it.
Yeah,
Hey,
I'm kind of with you on that, Chip. It really depends on those factors, reflectivity and the angle of incidence with the EDM and the surface that we're trying to scan. But I've always been really impressed with the SX instruments and just in their range. We've scanned concrete, asphalt surfaces, definitely out to you know, a few hundred feet, pretty successfully. So that's been my experience as well. I did have
Troy.
another question that came in, and that is the new option for the SX12 for the illuminated target, the TIL option under the instrument. And I can take a look at that when we get connected to the emulator. But do you have? Can you give an explanation of you know, a field application for the illuminated target?
Yeah, so that's essentially that flashing white light from the instrument. So it illuminates the target. If you think about looking at from the instrument perspective, so looking at that primary camera, it will light up that target. So even if you're not locked onto it, but it's within that frame of the primary camera, you'll easily be able to see it. And the application that's I would say most beneficial is going through some vegetation where you know, can't quite see exactly, you know, where you're going to pick it up. You turn that target identification light on, and it really helps you know, to the user see where that is, tap on it and lock, and then take that measurement. So I would say that that's kind of the primary use of that. And then
So,
Chad, yeah,
Thanks
go
for
ahead.
that. I appreciate that.
Troy,
uh,
can you hear me? Chad was going to jump in real quick.
yeah, if you can hear me, I mean, I sent a message to Frank. The only thing that I've seen on the asphalt really is that limits measuring to it is how high you can get the instrument off the ground, because you're dealing with the angle of incidence, right? If you could get that thing up 20 feet, which we know you can't, but if you could, you'd be able to scan, you know, huge swaths, right? But to get good coverage going down, I have a data set, maybe later I can pop that up, but it's about 60 feet from station to station if you're going to try to extract curb and stuff like that, just for a good overlap from one station to the next. It'll certainly measure further than that by a long range, but again, the angle of incidence is the biggest controlling factor on asphalt.
Hey, Chad, can you speak to the differences between the SX10 and the SX12 in terms of range? I think
There
you touched on
is,
that, but
yeah,
I
there
guess this
really is
question
none.
specifically about the SX10. So, what you know, what the improvement would be on the SX12?
You wouldn't see any difference in ranges. I mean, from that standpoint, they're essentially one and the same. So I wouldn't expect to see anything any difference between the two instruments in terms of range. The biggest thing, as we all know, with the SX12, it comes with the laser pointer. The camera in it is updated, right? So if you're going to do any kind of
All right.
imagery
Can you hear me again?
analysis, then the SX12 is better in that department. Also underground, right? So
I'm going to go ahead and just jump into it. If you guys can't hear me, let me know. So I'll try here one more playing the video and let's see if this works. But essentially, in this video, Riley is going to be kind of highlighting the scanning capability of SX12, as well as having your scans automatically georeferenced to your total station. So, why is that important to have them georeferenced in the field? Well, you can easily see the scan data as you're collecting it in that, that project coordinates. So instead of just having, scan on top of scan where you're just looking at essentially one a scan or one station setup at a time, you have every setup coming in with your project coordinates. So however you establish your station setup, if you're doing a backsite and setup on a known point, or if you're doing a resection, as it's scanning, it's going to be bringing those points into the data collector with your project coordinates.
What I love about the Trimble SX12 is I can use
still no audio.
It
well
as a robotic total station.
It's useful
but I
still
also
to
get
some of this.
that power of the
quick,
3D
we can hear it
here
now,
it's
Chip.
starting a
For
scan,
those that are
so
looking
you can
into
see
getting
that's
into scanning, this is a great instrument for you. I already know the workflows in Trimble Access, so I don't need to learn another software. And then using the survey workflow, using backside or resection, or the normal way I would set up a total station, that scan data comes in georeferenced automatically into the software. Your topographic shots, your total station measurements.
Hey Chip, this is Chad. We can hear the audio.
Project as your scan data. When you import that Trimble Access job into Trimble Business Center, not only do you have your topographic measurements, but you also have that scan data. It's automatically georeferenced to your survey control. And you don't need to spend hours doing the complex processing and georeferencing. It's all done for you, and it saves a lot of time.
All right, so now to take a look at the, there's a dynamic joystick that's built into Trimble Access as well. So this allows quick functionality to be able to have the laser pointer on and off. And then you have a traditional joystick or this dynamic joystick. So within the dynamic joystick, you're going to see the ability to be able to control how fast you're sighting the instrument. So again, that's the traditional joystick, and then this is the dynamic one. So with that, if you look kind of in the background, it's showing the laser pointer, and they're kind of showing moving it around to be able to sight the target. And then you can go to the slow, mode where you're basically, dragging at a more refined or controlled speed to be able to select, where you need to be. This is useful in some situations, maybe where it's a darkened environment and the camera isn't picking up as much detail, or you're out, where you're trying to measure maybe a reflectorless measurement. The camera is also, of course, you can go into this screen and just tap where you need to, and then you can use either that dynamic joystick on the screen, or you can use the arrow keys on the data collector if you're in a situation where you've got gloves on or something that is a little more tricky to use the on-screen interface. You can always use the keys. This is some of the changes as well, and as far as the stakeout routine. So this is really talking about the ability to mark the point. So if you're in an application, whether it's a mine or a tunnel, that's really easy to have it come on and flash there. On the office side, I'm just going to take a quick high-level view of this, and then when I'm finished here, we'll transition over to Chad to take a little more detailed look at some of the routines. But I wanted to at least go through and talk about some of the overall perspective. And we got one more video here from Riley. I saw in a comment that you guys are able to hear the audio, so I'm not going to talk just in case it's happening at the same time as Riley. But this one's a little bit longer. It's about 2 minutes, 2.5 minutes, I think. So as this is going through, if you have any other questions, feel free to type them in the chat, and then I just have a few more slides after this.
So next, we're going to take data from the Trimble SX12 and bring it into the office into Trimble Business Center. So you can take the Trimble Axis project, drag and drop it into TBC, and all of your topographic measurements, your total station control, and the scanning data will all be in that TBC project. So usually you start by looking at the total station data for any errors. TBC is very useful for this because it can automatically flag any issues in the total station data. So for instance, if I mess up a rod height, or maybe I need to disable some of the measurements in my traverse, I can do that in TBC. And the real benefit is it also updates not only the total station data, but as well the scanning data relative to those changes I make. After that, we can perform a traverse adjustment or a network adjustment on all of my data. And what's really cool here is that the scan data will update relative to that new adjusted survey control. Once all of the survey data is corrected and adjusted as necessary, now we need to take the scan data and clean it and get some deliverables from it. Scan data can be often an intimidating thing because there's so much data. What do I do with this? How do I get useful deliverables? TBC is very useful here as it can use the automatic classification to extract all of the noise out of your data set, so you can end up with a nice clean ground surface. You can end up with the poles, the trees, the signs, the buildings, and all the information you actually want out of the scan data, and taking all that noise and pushing it to the side. From here, we can use the feature extraction in TBC to extract key features for topographic surveys, such as curb and gutter on your roads, your poles and signs, and a variety of other features. Now, when you're ready to do your plan creation, whether it's for a boundary survey or a topographic survey, you can use that extracted CAD data and create topographic plans all in TBC. So while you're doing the drafting, and you maybe missed a few topo features while you're out there, maybe I missed a power pole or I missed a key sign I needed, well, this isn't a problem with the Trimble SX12 and TBC. First of all, using the virtual DR tool, we can extract 3D points from the scan data combined with the imagery and get a similar point that you would normally get with a topo shot. So not only can I collect additional features in the office, but it saves time by having to have repeated site visits. The great thing about the Trimble SX12 is you can also share all of this rich, detailed scan and imagery data with your clients. Your clients don't need to download any additional software or any additional tools, simply using Trimble Clarity to share that data. They simply open up a web browser and they can see the scan data, the imagery, the total station measurements, all in context of the project site. This is useful for projects that are ongoing, such as construction, where you want to see during the phases the update of that survey data over time. But it's also useful for showing the site conditions. So on a topographic survey, I may want to share that scan data to a client so they can see what the site looks like. Trimble Clarity is free for the first 2 projects, so it's easy to try out. And you can benefit from password protected links, so only you and your client can view the data if it needs to be confidential. If you happen to be using another CAD package to finish off your deliverables, no problem. You can export scan data, survey data, CAD data, all of it from TBC into your software of choice.
So at the end of that, Riley was showing a little bit of that Trimble Clarity. That's a platform that is it's a great way to collaborate with your clients or end users to be able to share access to the data. You control what they can see, and it's just it's a web browser type application, so they don't need to install any special software. They can just open that up and then be able to go in and see the data, take some basic measurements between points. If they're looking at, clearances or things like that, that's something that can be done directly in that web-based utility. Some of the newer features within Business Center that really helps with productivity for working with point clouds are these linear feature extraction routines. So it's able to turn data into 3D CAD information. So on that, what you see on the left there, that's essentially it's creating curb and gutter. Looking at this as a template-based approach. So you kind of create that profile, and then it goes through and uses the point cloud data to be able to extract along the curb set. So as Chad had mentioned, you do want to get a certain level of data coverage for this to be able to work well. But in areas that you do have point density, it's something that it's a really effective tool. There's also the capabilities to extract out overhead power lines. So that's something that the software can help generate those into 3D CAD. So rather than just having point cloud data, it takes it to the next step essentially. Virtual topo in the office with speed. So this is that increased productivity. So being able to measure codes using create point command. So you can do this. Again, this is in Trimble Business Center. So you can have a code group like you would have on the data collector and go through and pick out points from that the data set. So to be able to essentially do what we're calling kind of like a virtual surveying, and this works really well in combination with the CAD command line. Tunneling in TBC. So this Trimble Business Center has that option to be able to be a solution for tunneling type applications. So this allows you to do an analysis or an as-built. So to be able to, like an example of shotcrete, so you can use that scan data comparison with design to be able to get an inspection map there. Also has the ability to do some automatic noise removal when you're doing the classification. Classification in the scan module is, I think, one of the best tools that really allows you to quickly and easily strip out data that you might think of as noise, whether that's point clouds that were returned from obstructions or maybe vehicles that were passing through. So this is really an easy tool that not only strips out that noise or data that might be unneeded, and then beyond that, it can classify, into different groups, whether that's buildings, vegetation, ground, or structures like tunnels. Tank inspection. This is the workflow with our RealWorks solution. And if you want more information on that, that's something that we can follow up with. And then the scan essentials for SketchUp. So this is the ability to be able to work with the point clouds within SketchUp. So it's able to work directly from standard point cloud formats. And this is something that you can get through the SketchUp extension warehouse. And then Trimble Clarity. This is another tool here for collaboration and being able to visualize projects. This is a standalone web application, so you can view it on web browser, and you can also use this to share the 3D data. And this is a direct export from TBC, so you're able to select the data that you want to share in TBC, and then upload that to Clarity directly from Trimble Business Center. And then you can also control who you share that data with, and then have them be able to go in there and take a look or do some discrete measurements. So that's essentially the portion that I wanted to get through. That was kind of that overview of not only the SX12 instrument, but the full system, including the field data collector, Trimble Access software in the field, and the Trimble Business Center software